Welcome everyone, thank you for joining our Career Talk Fridays with STEM Ambassador Justin. Please feel free to put any questions you want to ask Justin in the Q&A box. Now over to you, Justin.
Hi, thanks Sophie, thanks James, and everyone at the STEM team. So hi everyone, my name is Justin Cassell, and I'm here today to show you a little bit about the oil and gas industry and what engineers are involved with. So I have 7 years experience working in the oil field industry with a company called Schlumberger. I worked as a geomechanics engineer briefly in the UK, and afterwards I worked as a field engineer in Saudi Arabia and in the United Arab Emirates. So I hope everyone has a pen and paper ready, note down any thoughts, any questions you might be thinking about, and we can discuss and answer anything at the end. So before I get started, just want to give you an idea of the topics I will touch base on today. I will first give a brief overview of the oil and gas industry, what it is, where we find oil, and what our engineers involved with. After that, I'll give a little bit of an insight on what I did in my career as an engineer. And then lastly, I'll show how the same skills and technology that we use in the oil and gas industry is being used for a zero carbon future. So to start off with, I thought I would give a very brief overview of what I was involved with as an engineer, because I think it will give you a good context. So here's a 2D cross-sectional view of the Earth. It's a very simple geological cross-section. We have different rock layers, we have a salt dome, and a very thin oil reservoir, 2 feet thick. So you might be wondering, how do we access this oil? In many cases, we will be drilling a vertical well, but sometimes this is not possible, like in this example, because we have a weak geological feature such as this salt dome. How about we directionally drill a well? This is possible. So by this I mean we can steer the well in any direction we want to go, up, down, left, right. We can navigate past any weak geological features, and we can access a large proportion of the oil reservoir. So you might be starting to think, well, Justin, how can we identify these different rocks, these different formations, and how can we even steer an oil well, considering what we're drilling with are these rigid steel pipes? This is something I'm going to show you in this presentation because it's what I was directly involved with. But before I get into all that, where does oil and gas even come from? So oil and gas is created from the decomposition of organic material millions and millions of years ago. A common myth is that this oil and gas is found in large lakes, caverns underground, and this diagram I'm showing you here kind of shows the same idea, right? However, this is far from the case. This diagram is a good visual to grasp the basic concept, but it doesn't tell you the full story. So oil and gas gets trapped in 2 types of rock, either a sandstone or a limestone. If you zoom into this rock, you'll see that it has a lot of pore space. On a microscopic level, it resembles a sponge. It has many tiny little gaps between the grains of sand and the particles that comprise of the rock. And so within these little gaps sits oil, gas, and even water. So oil and gas naturally migrate upwards due to buoyancy. So if we have a cap rock, then we can lock the oil in place and we can drill for it and produce it. This cap rock is a layer of rock that has very low permeability, which means it's a rock that no fluids can pass through. For example, shale. Shale is a very good cap rock, very common. So now we know where oil and gas generally comes from. What are some of the engineering careers available? And I'll be looking at the upstream sector. So upstream is anything from finding oil and gas, from the exploration of it, to producing it as efficiently as possible. So some of the main engineering degrees you'll find at university are listed here: petroleum, civil, mechanical, electrical engineers. If you choose to do something quite niche, like petroleum engineering, then you could have a career as a reservoir engineer. So these engineers create models of the Earth, just like that very simple one I showed you at the start, but they create very nice 3D models to calculate how much oil there is, and they plan on how to extract it the most efficient way possible. And you can see in this picture here, you can see the wells and all the little elements of the model, and they take in a variety of different measurements. This engineering role is typically office-based. Let's say you're interested in civil or mechanical or even electrical engineering. Well, you could be involved with designing the next megastructure, such as a semi-submersible rig, which operates in deep water. One of the advantages of a career in oil and gas is that you can study whatever interests you, and you can still get a variety of different job exposures due to on-job training by many companies. So for example, you could study any of these degrees and you could become a drilling engineer, someone who's in charge of planning, designing, and supervising the drilling of a well. You could even be an engineer in the research and development, designing the latest technology to locate and produce oil and gas efficiently. Or if you're interested in being at the center of the action, getting your hands dirty, you could be a field engineer. And field engineers use the technology to drill and produce for oil and gas. So these careers are only the tip of the iceberg. There's a huge variety of jobs available in oil and gas industry. And the main point here is that with any engineering background, there's many opportunities. But no matter what you do, most likely you'll be touching base with the earth sciences. So you'll be incorporating geology, petrophysics, geophysics into your line of work. And it's okay if you don't study these at university. That's no problem, because many of the companies that you'll work with, they will teach you these things as you go. Another advantage of a career in oil and gas is that nothing is stagnant, nothing stays the same. So for example, you could start out as a field engineer working on the rigs. Then you can move to the office and become a drilling engineer. You could even become an engineer at one of the technology centers. For me, I studied mechanical engineering. With this alone, I could have become a field engineer straight away, but I was very interested in this industry, and I thought I'd like to do a master's in petroleum engineering. After my studies, I joined Schlumberger as a field engineer, and I worked there for about 2 years in Saudi Arabia and 2 years in UAE. What is field engineering? So field engineering is engineering combined with geology and petrophysics. So petrophysics, just in case you don't know, is the chemistry and physics of the interaction of the fluid and the rock in the subsurface. So as a field engineer, we use technology and we take measurements of what's beneath us. So we measure things like the natural radiation of the earth. We measure the electrical resistivity of the fluid that's within the rock. We measure how dense the rocks are, and we measure how porous the rocks are. Many more measurements too. We have pressure, we sample the fluids, they get the chemical composition. There's a variety of measurements that we do. So let me show you a very simple example of what I typically did. So let's say we're about to drill a well. And let's say we're about to drill and measure for gamma ray, so highlighted here in the green. And then we're also going to measure the resistivity, which I show here in red, as well as the density and the porosity on the right side of the track. So as we drill, our tools are taking measurements of what's beneath us. And we plot these data points on a log. Next, field engineers would have to decipher what is going on to make sure the data looks good before we pass it on to our client. And by the way, this data that we measure is used to create the 3D models, which I showed you in the previous slide, which reservoir engineers or geoscientists work with. So looking at this log, well, from this log, it looks like we have three zones of interest without getting into the detail of things. We have 3 zones here. It looks like in the first zone, we have shale. Looks like in the second, we have a sandstone with oil and gas. And then beneath this, it looks like we have the same type of rock, sandstone, but with water. So you might start to think, well, Justin, how do you know this stuff? You're just making things up now. But if you apply some fundamentals of physics and what you have learned in school so far, you'll start to understand what's going on in this log yourself. So for example, oil is very resistive. So where we identified oil and gas, the resistivity, the red curve, has gone up. Salt water is conductive usually, right? So towards the bottom, we can see the resistivity curve in red has dropped off quite significantly. This means we have a conductive fluid in the rock. So this is a very simple example to just give you an insight of what we did. Next, I'll show you something a bit more complicated that's also possible. So this is a 2D cross-sectional view of the Earth. Just a slab of rock, right? Don't worry, this is just a picture. This is not how it actually looks like. It's just to give you the idea. So let's say we're about to drill a horizontal well with a tool called Geosphere. So this tool measures resistivity. It takes electromagnetic measurements and it creates a map of the resistivity. So let's see what this looks like. As we drill, we don't know really where the oil reservoir is, but we're mapping the electrical measurements, the resistivity. And as we drill, we can identify the boundaries of our oil reservoir. So we know how far above us is the top boundary, and we know how far beneath us is the bottom boundary. And that red dot I showed you is actually the path that we drilled. It was directionally steered. So the steering of this well was made possible by a tool called a Rotary steerable system. It's a pretty cool tool. We can communicate to this tool. So when we need to steer the well, we communicate to it and tell it where to go. So for example, in this horizontal well, if I wanted to go down, I'd action the tool to use these pads for the pads to push up against the rock above it. And when it did that, the whole tool can start to bend or start to move downwards. It pushes the tool down. It pushes the drill bit down. And these pads are located all around the tool. So if we need to go to the left, we have the pads on the right of the tool pushing towards the right, and so forth. Actually, the same technology that's in this tool is actually the same technology that steers a helicopter. So I applied technology like this in the Middle East. I was lucky enough to work in the deserts of the Empty Quarter in Saudi Arabia. I also worked in the Persian Gulf. I worked offshore. So a really cool part of this job was that I got to work in very remote locations, very far away from people. In the bottom example, I think I was 10 hours by car from the nearest town. So it's quite far away. And I really enjoyed this aspect. It was, it's not working in the office. Every day was different. Sometimes the elements would catch you out. Sometimes we had dust storms. It was something new every day. So when I went to the rigs onshore, this would involve driving for several hours through the desert, often seeing camels. I've got hundreds of pictures of camels. If I worked offshore, we'd be taking helicopters. And when I was on the rig, I would be there for 3 days to 4 weeks. It just depended on the length of the job. So this is an example of a rig. The structure is probably around 100 feet in height, so it's quite large. So while on the rig, after setting up the equipment, I would monitor the drilling and gather the data while sitting in my logging unit. I just showed you here in the top right image where my logging unit would be and what it kind of looks like. It's just a steel container, pretty much. And it had, most importantly, our AC, and it also had all our computers, so we can see what we're doing in terms of drilling. The bottom right picture is a picture of one of the offshore rigs I was on. It's a very different environment. It looks very chaotic, lots of steel, no space. Space was a luxury item on this rig. So even if you wanted some quality time to yourself or do some exercise, you'd have to run in circles on the heli deck. Last thing I wanted to show you was how the skills I developed in my career, as well as other engineers in the industry, are relevant towards a net zero carbon emissions future. So for example, the main one that may come to mind is the geothermal energy. This is where we drill wells and we extract hot water. This hot water creates the steam that powers the turbine, creates electricity. And we push or we pump this hot water back into the ground to be reheated by the earth before we extract it again. So it's a cycle. So oil and gas engineers are involved with drilling these wells, and they use the same sort of tools in locating oil as they do here. So they take measurements to make sure we optimally place the wells to make this process of geothermal energy as efficient as possible. Just today in the news, and as well as yesterday, I saw that the UK has finished one of its main geothermal projects down in Cornwall. So over there, I think they drilled over 5 kilometers deep. It's a pretty huge geothermal well that they drilled. And our engineers from my company were actually involved. So they were using tools to measure the permeability of the rock. And the permeability of rock means how easy a fluid like water can move in the rock between the pore space. This was really important because we want to make sure that where we have the geothermal, we can efficiently produce the hot water to create the electricity. Another important technology is carbon capture and storage. So with this, CO2 is captured from energy power stations, from cement factories and steel plants, and it's pumped underground and it's stored in geological formations for thousands of years. So personally, I was involved with drilling wells, which were used to pump CO2 underground. And in most of these cases, this actually was done to increase oil production. So when you pump CO2 into the rock, it pushes the oil out to the other side where you extract it from. So this process is called enhanced oil recovery, and it's a quite common term in the oil industry. Other engineers, such as reservoir engineers, will be involved with modeling the storage of CO2 underground. And it's a really important job because we need to make sure that whatever we pump underground stays there for thousands of years, right? So the geology in the reservoir is adequate. Engineering is all about using science and technology to solve complex problems. So for engineers in the oil and gas industry, this typically involves adding or incorporating the earth sciences like geology to help address the energy demand of the world. So it's a pretty exciting industry. So a career in oil and gas could lead you to develop the latest technology to locate for oil and gas. And by the way, NASA uses quite a lot of technology from the oil and gas industry and many of their expeditions to outer space on Mars, for example. You could be part of modeling the next CO2 injection for a carbon capture and storage project. You could even be designing the next geothermal well for zero carbon energy. So for me, the best part of a career in oil and gas involves working with many different people from all over the world. This has always been very enjoyable. And this could be in the field, on the rig, or it could even be in the office. And on top of that, you could be working all around the world. And this global perspective is even the logo of one of our main societies, the SPE. So I hope you showed a little bit of the insight I showed here today for oil and gas and showed you something new, hopefully, and you found it enjoyable and interesting. I'm happy to answer any questions or discuss anything. If you found those logs interesting with the resistivity mapping, we can discuss them in more detail. Thank you very much for listening.
Thank you for that, Justin. So we have firstly a question. What inspired you to become an engineer in the oil and gas industry?
Okay, so it's a great question. I was fortunate for I have family members who work in industry. So I got to see kind of firsthand from a very young age what the industry typically is made up of and the opportunities that were available. So I always liked the idea that you can work anywhere in the world, you can work in remote places, you can work outside. So yeah, from exposure from the family, it's what led me to it.
Lovely. And what's it like working on an oil rig is another question we've had in.
Very interesting. Also a good question. So typically, oil rigs never shut down. They're operating 24 hours a day, every single day, even on Christmas, right? So there's no break. So you work with a team, very close-knit team. It's like a family when you work on a rig, and you work 12-hour shifts. So you could be working a day shift, a night shift, and you work with your team. So once your 12 hours are done, you have 12 hours to yourself on the rig to watch movies, sleep, do whatever you want. And when you're on the rig, every day is different. You know, there could be new problems to solve. There could be, every day was different. It's hard to describe a typical day. But the common theme across any job on a rig is working with some great people, like-minded people.
We have also had a question that leads on from that, actually. How many people would you work with when you work on the oil rig?
Okay, yeah, so within my company, with Schlumberger, we'd be working in teams of 4 typically. So there'd be 2 people on one shift each. But that's just from my company, right? So there could be 70 to 100 different people on the rig. It depends on the size of the rig. You have some mega structure rigs that you find off the coast of Africa, Gulf of Mexico, these deep water rigs, and they're quite big. And because of that, they need more people to operate. So you could be looking at 100, 150 maybe. But I think typically for the rigs I was on, typically 40, 50, maybe one of the bigger ones, maybe a little bit more, but 40 or 50 people is kind of the range. I never counted actually, but I remember seeing a lot of faces all the time.
Oh wow! Did you make friends with people on the rig?
Yeah, you get to meet people every single day. It's hard to keep track with everyone since you're meeting so many people all the time, but it was great to meet many people from different backgrounds.
Fantastic. Okay, so we have some more questions that have come in. We've got one that says, what are the differences you find from country to country for the future of a zero carbon future at the moment?
I think it's a great question. I think the topic is gathering momentum, which is great. Being in UAE, they're really on top of being net zero and looking at a future of zero carbon. So UAE is actually having quite a few carbon capture and storage projects going on. So they're going to be capturing CO2 from the steel and cement factories and pumping them underground. And then the exposure here in the UK, you see it on the news all the time. That's a very important topic. So the industry is even looking at how to make their operations more efficient with less emissions. So I think there was always this classic picture that a rig has a flare off the side. There's always something on fire. You know, they're burning off the residual gas, the methane. This sort of stuff is stopping. They're really changing the way that they operate, so they operate cleaner. And I find this all over the world. It's really gathering momentum in the last kind of couple of years.
Fantastic. And what are the main routes into becoming an oil and gas engineer is another question we've had in.
That's great. It's variety. You know, if engineering doesn't attract you as much, there's a variety of scientific or roles with technology. I would say if you're interested in science, pursue a career or a course in geology, geophysics, some of these earth sciences. The beauty of the industry is that even if you study geology or geophysics, you could still become an engineer in your career. It doesn't stop you. And if you want to become an engineer, then study whatever interests you, right? Whether it's mechanical, civil, fluid mechanics, petroleum engineering. Wherever you go, companies usually train you. They train on the job. So when I joined Schlumberger, I had about 4 months of training. I was not actually working on the rigs. I was in their dedicated training center, and they train you to make sure you have the right skills, because you're working in places where you need to have the right skills. So, you know, when I was 10 hours away in the desert, I couldn't just phone up and say, I don't know how to do this. So they make sure everyone is trained, know how to do things. And that's also another attraction, the amount of training we receive. But yeah, in a nutshell, do whatever interests you, whether it's geoscience or engineering. And if oil and gas or even the energy industry interests you, there's many possibilities.
Brilliant, thank you. So that concludes our talk for today. So I just want to thank Justin for doing that for us, and also to thank everybody listening. Thank you, then.
That's great, thank you.